In this tutorial, we are going to see how you can quickly evaluate the square of numbers ending in 5. Here I have several numbers that end in 5 and their square is evaluated. I want you to pay close attention to the pattern of the square of these numbers. What pattern do you see here? Do you see that the square of a number that ends in 5 always ends in 25? All of them end in 25. Now take a look at the number that's not 25. The number in the hundreds place or the thousands place. Let's see how you can relate this number to the original number. For instance, 15 squared equals 225. I have a 1 and I have a 2 here. 25 squared, 2 is 625. I have a 6. 35, 3 equals 1225. I have 12 here. And 45 squared is 2025. What kind of relationship do you see between the number and the square of it? You probably notice that this number 2 here is 1 times the number next of it, which is 2. 1 times 2 equals 2. 2 times the next number 3 equals 6. 3 times the next number 4 equals 12. And 4 times 5 is 20. Do you see this pattern? Do you think you can try out some of the square? Okay, so let's try it out. So here I have listed a few numbers and I want you to evaluate their square using the trick that we just learned. So you can pause this screen a little bit until you have evaluated the square using the method that we have just seen, the pattern that we just seen. For the big numbers, if you get stuck, don't worry. Just keep on playing the video. We'll go over them each one of them. Okay, what do you get for 55 squared? As we said before, all square end with 25. What about the number before 25? Since we're talking about 5 here, so we take 5 times the next number, 5 times 6. So the answer is 30. Did you get that? Next one, 65 squared. Again, the answer ends with 25. And then you take this number 6, multiply to the number next of it. So 6 times 7, and you will get 42. And then for 75 squared, you do the same thing. It ends with 25. 7 times 8 is 56. 95 squared, still follow the same pattern, 25. And then 9 times 10 is 90. You can always verify this with a calculator. What about 125? Now we are in a 3-digit number. The rule doesn't change. It's still 25 at the end. But now we're going to multiply 12 to the number next of it. So it's 12 times 13. How do you evaluate 12 times 13 mentally? Since we're talking about a quick way to evaluate the square, we're not going to use a lot of pencil and paper to do it. And we don't touch the calculator either. How do you evaluate 12 times 13? Well, a lot of students remember 12 square. That is 12 times 12. A lot of students remember that that is 144 because this number comes along very often. But now instead of 12 times 12, I have 12 times 13. That means I need one more set of 12. I'm talking about 13 sets of 12 instead of 12 sets of 12. So I need one more set of 12 on top of 144. So this number is 144 plus another set of 12. And hopefully you can mentally do this addition. So it will be 156 because I add 12 to 144. All these things I'm showing on the board, but over time, over practice, you will be able to do it in the head. So 125 squared is 15625. How about 205 squared? So we have 25 at the end. 20 times the next number, which is 21. Again, we use the same trick that we used for the 12. So let's do 20 times 20, which is 400. Let's do it in our mind now. So 400 plus one more set of 20. So it's 420. Now we come to 355 squared. Now this is a big number. It looks kind of complicated too, but it ends with 25 for sure. How do you evaluate 35 times 36? Okay, without using pencil and paper, I'm just showing you this. Hopefully you can do this mentally. So we want to evaluate this. Is there any quick way to do 35 times 36? Well, let's figure out what 35 times 35 is. And then just add another set of 35 to that. But what is 35 times 35? It's not a square that we used to know, like 12 square that is pretty much imprinted in our mind. What is 35 square? Well, it is actually something we just learned today, or what we are learning today. 35 square, remember? A number ends with 5, right? So 35 square is something that ends with 25. And then I have 3 times 4. So 1225. I think we have seen this one in the previous slide. 1225. However, that's not enough because what we want to do is 35 times 36. So we need another set of 35 to add on top of 1225. So add 35 to that. And we will get 1260. So this is our answer. 126025 is the square of 335. If you don't believe that, you can pause the video and then pull out a calculator to verify all these. So you may wonder, how come there's such an interesting pattern in the square of a number that ends in 5? And does it work for all numbers or just for some of the numbers that we have seen so far? Actually, there is an algebraic proof that it works for all numbers that end in 5. And here is the proof. A number that ends in 5 can be written as 10a plus 5. Now, what do I mean by that? Let's take a look at some examples. So for instance, if I have 35, I can write it as 10 times 3 plus 5, because 10 times 3 is 30. 30 plus 5 is 35. Or if I have a number that is 205, this number also ends in 5, then I can write this number as 10 times 20 plus 5. So do you see that? 3 here, 3 here, or 20 here, 20 here. So if I have a number that looks like A5, remember the A is in the tens place, or A can be more than one digit long, then it's like in the tens, hundreds, thousands, and so on place. So it's always 10 times more than a single digit, than the ones digit. So it's 10a plus 5. All numbers that end in 5 can be written like this. Okay, so in order to evaluate a number that ends in 5, the square of this number, so we can write it like this. 10a plus 5. So if you're thinking of calculating 35 square, then a would be 3. Or if you're thinking of 205, then our a would be 20 in this case. So it's 10 times that number plus 5. And then we do the square of it. And the square of it can be written as this parenthesis times itself. And then we will apply the distributive property to evaluate that, to do this binomial expansion or algebraic expansion. So I will take the 10a times the 10a, and then I will get 100a squared. And then I will get the 10a times the other one in this parenthesis, which is 5. I will get 50a. And here I have 5. Now is the term of 5. 5 will multiply into both terms in this parenthesis. The first one is going to multiply to is 10a. 5 times 10a is also 50a. So in this case, I get a total of 100a. And lastly, 5 times 5 is 25. This may remind you of something that you have seen before. A plus b all square is a square plus 2ab plus b square. Now this a is not the same a that we are talking about. It's more like a general variable. So after the expansion, so this is what we get. And then I'm going to do some trick with this line. I will copy the 25, no change. But for these first two terms, I'm going to factor them. I see that both terms have 100a. They both have 100a in it. And this term is actually 100 times a times another a. So if I pull out 100a, I still have an a here. I'm doing like the reverse of the distributive property now, distribution. And here, if I take 100a, it seems like I am left with nothing, but actually it's not nothing because this is 100a times 1. So what I got left is 1 here. So after factoring these two terms, I ended with this. Now what's so interesting about this line here? Now we see that this number ends with 25, and this part, you see this a and a plus 1. Now remember, a is the number we're talking about, like in the example of 35, a would be 3. Then what is a plus 1? A plus 1 is the next number higher than a. So if our a is 3, then a plus 1 is 4. So it's 3 times 4, right? In this example here, 35. Or in the example of 205, it will be 20 times 21. And then we take this result, multiply by 100. So in the case of 3, 5, 35 right here, what we will get is 100 times 3 times 4 plus 25, which is 100 times 12 plus 25. So that becomes 1200 plus 25, and that is equal to 1225. And you can do the same thing for the other example, 205 here. So that's the algebraic proof of why we can use this pattern, use this trick to quickly evaluate the square of a number that ends in 5. Thank you for watching.